To find the equation to the straight line which cuts off given intercepts A and B from the axis, so let me draw. This is A and this is B, the length I'm talking about. So we have to find out the equation to this straight line AB, and it goes on to infinity. This is the straight line to which cuts off given intercepts A and B from the axis. So we have to find the equation of this line. Now, first of all, let me tell you the coordinates of point P. So point P has a coordinate x, y. Alright. Now we require a relation that always holds between x and y so long as P lies on AB. I mean, that is what defines the equation. Alright, so I'm going to use geometry here. So I'm going to write it, and let me change the color real quick. There you go. So by geometry, I can write OM upon, or divided by OM divided by OA is equal to PB upon AB. So this is my first relation. Keep in mind, M is a point on x-axis, A is a point on x-axis and on line, and B is also a point on y-axis and on line. Okay, so by geometry I have my first relation. OM upon OA is equal to PB upon AB. That's just simple ratios derived from ratios. Alright, so this is my first relation. My second relation is MP divided by OB. OB is equal to AP divided by AB. Now this is similarly obtained from ratios. This is my second relation. Alright, and now what I'm gonna do is I'm gonna add 1 and 2. I'm gonna add 1 and 2. Alright, so after adding 1 and 2, what I get is OM upon or divided by OA plus MP divided by OB is equal to PB upon AB plus AP divided by AB. I'm adding LHS of both the equations, and I'm adding RHS of both the equations. Now I'm gonna say that this is equation number 3. Now what I obtain from this equation? Well, let's solve it. OM is this thing. Wait a second. OM is this. So this is also equal to x. So OM is equal to x. And MP is this thing. MP is this. And MP is also equal to y. Alright, now OA is let me change the color. OA, this thing here, is basically small a, and OB basically is small b. So we can write 3 again as x divided by a plus y divided by b is equal to PB plus AP divided by AB, which we get as PB plus AB. So PB, this thing here, plus AP, this thing here, is equal to AB. So what we get is 1. So the equation to the straight line which cuts off intercepts A and B from the axis is obtained as x divided by a plus y divided by b is equal to 1. So this is the required equation that we have to find out. Now there is another way to obtain the same equation. What we're going to do right now is we have a triangle OAP, we have another triangle OPB. So the area of triangle OAP plus the area of triangle OPB is equal to the area of triangle OAB. This is true. This is another equation. Alright, and using this we can obtain the required equation, and we already know what the required equation is. I'm going to write it here, and there it goes. X divided by a plus y divided by b is equal to 1. So this is our required equation. Now how do we obtain this equation from there? Alright, so the area of triangle OAP, well, I'm going to write it as half of base and height. Half of base into height, that is equal to half of a into y. And the area of triangle OPB is again half of base into multiplied by height, which is half of b into x. And the area of triangle OAB is equal to again half of base multiplied by height, which I'm going to write as half of a into b. Now all we have to do is put 1, 2, and 3 in equation number 4, and we are gonna write it as half of a multiplied by y plus half of b multiplied by x is equal to half of a multiplied by b. Let me change the color. Yes, now the half cancels, and what we are left with is x into b plus a into y equals to a into b. Now divide both sides by ab, and what we're going to get is x divided by a plus y divided by b is equal to 1, and this is the required equation from way number 2.